Today we are going to discuss some practice problem based on P.M.I. So first problem is that prove by P.M.I that x raised to the power n minus y raised to the power n is divisible by x minus y. So for n is equal to 1 clearly result is true because x minus y is divisible by x minus y. For n is equal to k, let us assume the result that x raised to the power k minus y raised to the power k is divisible by x minus y, or x raised to the power k minus y raised to the power k is equal to x minus y whole multiplied with m, where m is any natural number. Now let us prove the result for n is equal to k plus 1, that is x raised to the power k plus 1 minus y raised to the power k plus 1 is divisible by x minus y. Now let us start from this expression x raised to the power k plus 1 minus y raised to the power k plus 1, where x raised to the power k plus 1 can be written as x raised to the power k into x by law of exponent. Now from equation number 1 I am putting the value of x raised to the power k by shifting this to the right hand side. So I am putting this value here so that this is multiplied with x. Now open the bracket, but don't open all the terms because we have to show this exclusively. So next I am taking y raised to the power k common from second and third term, and we are left with x minus y. Now we can take x minus y common from these two terms so that we are left with mx plus y raised to the power k, and hence it is true for n is equal to k plus 1. So thus it is true for all natural numbers. The next question is very important. Prove by P.M.I that 7 plus 77 plus 777 plus up to so on 777 up to so on 7 n digits. That means in first term there is 1 digit, in second term there are 2 digits, in third term there are 3 digits. So in nth term there are n digits. So this is equals to 7 by 81 into 10 raised to the power n plus 1 minus 8n minus 10. Now obviously for n is equal to 1 it is true. For LHS is this value is 7, not 1. Let I correct this term, it is 7. Now for RHS it is 7 by 81 into 10 square minus 8 minus 10, which is 81. So overall it is 7 left. So for 1 is equal to for n is equal to 1 it is true. Now let us assume the result is true for n is equal to k, that is put n is equal to k everywhere. So this is my equation number 1. Now let us prove the result for n is equal to k plus 1, that is we have to prove 7 plus 7 plus up to so on up to 777 k digit plus up to so on 777 k plus 1 digits. So this should be equals to, I am putting n is equal to k plus 1 in the right hand side, which after simplification becomes 7 by 81 into 10 raised to the power k plus 2 minus 8k minus 18. So now left hand side is, again I am writing the full left hand side, and up to kth term I am putting the value from equation number 1, which is this equation. Now I am putting the value here. Now this is the most important part of this question, that I am simplifying this term. How? Reason is there. 7 can be written as 7 into 1, then it can be multiplied with 9 and 9, multiply divide by 9, and this 9 can be written as 10 minus 1. Similarly 77, this is 7 into 11, then again multiply divide by 9, so it becomes 99, and this can be written as 10 square minus 1. Similarly for third it can be written as 10 cube minus 1, and so on, so that the number of 7 are there, that is power of this 10. So I am writing this as this term as 7 by 9. There were k plus 1 digits, so I am writing 10 raised to the power k plus 1. So this. Now to make the calculation easier, I am multiplying and dividing this term by 9, so that I am having 7 by 81 in both the terms, and I am taking this common. After that, now obviously I can take common 10 raised to the power k plus 1 from these two terms, so that it is 10 raised to the power k plus 1 into 10, and by law of exponent it is 10 raised to the power k plus 2. And finally this is equals to right hand side. Thus by PMI result is true for all natural numbers. Next, prove by PMI that 1 plus x whole raised to the power n is greater than equals to 1 plus nx, where x is any positive integer and n belongs to n. Positive integer. Now, for n is equal to 1, this is true. Now for n is equal to k, we have assumed the result 1 plus x whole raised to the power k greater than equals to 1 plus kx. Let this be equation number 1, inequality number 1 rather. Now we will prove the result for n is equal to k plus 1. So starting from, it is 1 plus x whole raised to the power k plus 1 is greater than equals to 1 plus k plus 1 multiplied with x. Next, I am picking the left hand side. So writing 1 plus x whole raised to the power k plus 1 again. Then what I am doing, I am using law of exponent and separating this factor so that I can put the value from inequality number 1, which is this, and I have put the inequality sign here. Now open the bracket. After that, from second and third term I am taking common to show that this is right hand side plus something extra. So I am removing this something extra and putting one more inequality sign. So this is equals to right hand side. So finally LHS is greater than RHS. So there is greater than sign, and for n is equal to 1 there is equality sign. So by combining these two we can say result is true for n is equal to k plus 1 and it is true for all natural numbers. So that's it. That's all for today. Take care. Have a nice day. Thank you.